Welcome back to the channel, and on this occasion we are testing out the inductance measurement function on the MTR105. Now the MTR105 has an inductance range of 2 millihenries up to 1 henry, and with the resolution of the device it will actually read from 1 microhenry up to 10 henries. What I actually have here to test this out is a little inductance decade from time, and also 2 or 3 little individual inductance coils as well. To the right I have an Appellant AT2817A LCR bench meter, and that will provide me some reference readings for some of the inductors, but I do actually have a UCAS certification on the inductance decade, so I'll be able to use those values as a comparison for the readings from the MTR105. Now, in terms of the other 2 instruments, neither of those instruments will actually measure inductance. The MetraHit Coil actually has a rather unique winding interturn test function built into it, which is one of the purposes of the inductance function of the MTR105. So whilst it won't give me a direct reading of inductance, I will be able to demo the testing of that MetraHit with some coils of wire that I have that you can just see in the background, and to test them on the coil test adapter that comes with the MetraHit coil. I'll also be able to measure the inductance of those coils as well. Now you see the U1461A from Keysight is not in the picture because that does not have any inductance or winding short function built into it, so it is not taking part in any of this test whatsoever. Okay, I'll rearrange things and get set up to show some inductance measurements. Okay, so we're set up with the MTR105. I'm just going to run it through calibration procedure first. I'll switch it to a manual inductance mode. I'm going to leave it on 1 kilohertz. We'll go for calibration, which is the same process as it is for the capacitance function. So it takes a few seconds. 2-point calibration. First one here is open circuit. That succeeded. So now we'll go for a short circuit. Okay, calibration succeeded. So I've got here a 4.7 microhenry inductor. I'll give him a measure. 5 microhenries. 4. Yeah, trying to figure out between the 2 of them. We'll try him on the Appellant. 4.32, so closer to the 4 than it was to the 5, but the MTR105 was there or thereabouts. This one should be 68, I believe. Smack on 68. Try him on the Appellant as well. 66. So again, pretty accurate reading. I'm not too worried about that. So we'll just pull these off and go for some inductance decade measurements. And I'm just going to do the same as I did with the capacitance test and just switch through these inductance values. There's 1 millihenry, hit the go button. 1.986. Add in 10 millihenries. 10.7. Quite a steady reading. I'll add in 100 millihenries, so that should be 111 or 110. And we'll add in 1 Henry. Okay, so we're a little bit out there. Take him up to, not sure, 10 Henrys here, perhaps a bit open circuit, perhaps be too much for it. We'll see what we do on the 9 Henrys. 9.25. Yeah, good steady reading, reasonably quick. Let's see what this is like on the applant. Now, because the applant is 4 wire, I'm just going to stick those 2 adapters in there. So we're at 8.9 against 9.25. We need to go back to our inductors, so don't we? Go down to. So that's the 1.111, which is 1.09, and it was 1.10 on the MTR105. So that's pretty reasonable. Go the other way with this, 110 millihenries, 110.6. That should be 11 millihenries, and we're on 10.9. 1 millihenry is 0.997 or 997 microhenries. I think we're on 985 microhenries on the MTR105. So that gives you a taster of what it's like for inductance measurements. I'll reset all of this with the test coils, and we'll show what the MetraHit coil does alongside the MTR105. Okay, so we're set up with the MetraHit coil and the MTR105. I've got 1 coil of wire in here to take a measurement with. You can see I have the test coil adapter for the MetraHit here. That is wired directly onto the coil as though I was taking an inductance measurement, and this adapter is in turn wired back onto the meter itself. I'm set over to the insulation test function. Instead of using the insulation test, I have to use this button over here, and you can hear it clicking away. Now I get a microsecond reading of 74.7. So I'm just going to stick another coil in series and hopefully get a reading from there. And hopefully we should get a higher reading this time. There we go, up to 94.1. Now, the issue that I've had with the MetraHit is that when testing motors, this function doesn't always work. And with the original coil test adapter, I wasn't too successful with the kind of motors I had. I did send all the test data off to Gossen Metrawatt. I never ever got a response from them. So in the end, to try and get some more out of the instrument, I actually built up my own little test box to replace this adapter, and that gives me some different ranges, which allows me to test some of the larger motors that I operate with. On the other hand, MTR105, you see over there, I have never had a problem with it. I've always been able to get an inductance reading out of it on any motor I tested. So we'll just do these 2 coils quite quickly. 1.67 millihenries there for the initial one, and you can see the other thing is that the reading stays there until you disconnect. 1.05 millihenries there, so it works fine, no problems. As I say, it's worked on all the motors that I've tested with this, and it holds the reading whilst you leave the leads on. Gives you a little bit of time to write down or save it and record it if you want to, whereas this MetraHit, you cannot save the reading. and as soon as you let your finger off the button, the reading goes. Because it's a high voltage test, the instrument switches to a discharge mode to get rid of any voltage that's in there in the coil. So there you have it. There's some inductance measurements done with the MTR105. Quite an easy win for this instrument. I'm going to put that in first place, 5 points. I am going to give the MetraHit Coil second place and 3 points, and the U1461A, that's going to come down to 0 points because it doesn't have the function on it really, and there's no workaround that I can do. It will just be a resistance measurement with that instrument, which both of these two instruments can carry out anyway. So that will be third place and 0 points for that one. That's it for this video, and I think that actually completes all of the measurement functions on the instrument. I do want to display the guard terminal used during an insulation test, but I'm still waiting for some bits to do that with. So the next video on the MTR105, I'm going to look at the battery consumption on the instruments and do a cross comparison of that.